Okay, let's start 9.7, circles and lengths of segments. I think this is the hardest section of chapter 9. Okay, so before we start, I want you to see if you can remember all the theorems and corollaries that we learned in the first 6 section by memory. So in the section 1 and 2, there are 2. Well, one was the converse and the conditional, and then the other one is a different one. So there are 2. In section 3, there were 2. And on 9.4, there were 3. 9.5, there were 5. And 9.6 that we just did, there were 2. Okay? See if you can remember it without looking at your list. Maybe draw a diagram and remind yourself. Okay? All right, you don't get to see the summary sheet during the test, so it's important that you can remember it. Okay? All right. Is this right? Okay. So objective 3 for 9.7, solve problems involving length of chords, secant, and segments, and tangent segments. Okay? All right, so here is segment of chord. That's just the kind of vocabulary. You can use similar triangles to prove that lengths of chords, secant, and tangents are related in interesting ways. In the figure at right, chord AB and chord CD intersects inside the circle O, and PA and PB are called segment of chord AB. So this is segment AP of chord AB, segment PB of chord AB. As we did with the term radius and diameter, we will use the phrase segment of a chord to refer to the length of a segment as well as the segment itself. So it refers to both the geometric figure and the distance between 2 points. Okay? And here's 9.11. When 2 chords intersect inside a circle, the product of the segment of one chord equals the product of the segment of the other chord. So what it means is that AB and CD intersect at P, R times S is T times U. So product of one chord, the segments of one chord equals the product of the segments of 2 chords. This times this is this times this. And that's coming from the fact that these 2 triangles are similar. So my dog's making a sound. Okay, because these are congruent, right? Vertical angle. And these are congruent because it's intercepted the same arc, right? And if you look at these angles, it's intercepting the same arc. So these angles are congruent, and therefore these triangles are similar. So any 2 chords intersecting inside the circle, if you draw these triangles, they're always similar. And because they are similar, the corresponding side are proportional. So this over this is this over this, and cross multiply, and you get this. So that's what this proves. Okay. So fill this out, the question marks, okay? One of these proofs, I may put it on the test, so make sure you can do this, okay? And here's the example. So solve for x. This is homework. So just use this to solve this. So this times this is this times this, basically, okay? All right. And here is theorem 9.11 and 9.12 and 9.13. For proof of the following theorem, see the classroom exercise 7. In the diagram of the theorem, AP and CP are secant segments, BP and DP are exterior to the circle and are referred to the external segments. The term secant segment and external segment can refer to the length of the segment as well as the segment itself. Okay, so now the intersections outside, just like when we did this and then angle, this angle, right? If we move there, it's a 0, and then if you when there, it become it's the same kind of movement inside to the side, and then now it's outside. So we know that this angle right? This measure of angle is this 1/2 of this minus this. That's what we did in 9/6. Now we are talking about the length of the segment, not the angle. Okay, so the 9/7 refers to the length, not the angles. Okay, and in this, if the intersection is outside the circle, RS, so the outside to the whole thing, is outside to the whole thing. Outside times the whole thing is outside times whole thing, because these triangles are similar, and the lines you want to draw is this. Okay, so now we have these angles shared, right? And this angle and this angle are congruent because it's intersecting this arc, right? So then it's angle, angle, and these two triangles are similar. So this over this is this over this, cross multiply, and you get this. Okay, so that's what this is, 9, 12. And just like we made this one to a secant and tangent, right, for the angle, we did this minus this, 1/2 of this. This is 1/2 of this minus this. You can do that for tangent as well. Okay, so you know, you move this, and then once the the PD coincide with PC, like here, then it become the outside times whole is outside times the whole, because the whole and outside is not now the same. So RS is PC square, or T or U square. So the theorem 913 says, when a secant segment and a tangent segment are drawn to a circle from external point, the product of the secant segment and its external segment is equal to the square of the tangent segment. Okay, so you have to do problems to kind of get the idea of what we are doing. So here, so I want you to do this, but so this times this, so 4 times 9 is 3 times 3 plus x. Don't do 3 times x, 3 times 3 plus x. And 4 times 9 is y squared, okay, because this is tangent. Okay, and here is the practice. So how many practice we got here? You have 6, 7, and an exercise. Okay, why don't you do odds for homework here? So you're doing 1, 3, and 5. Okay, and I want you to do this one as well. We already talked about how to prove this. Supply the reason to conclude the proof 912. Okay, so here is the proof. I want you to write down the reason next to it, okay, to prove this. I don't think we need to do any of this. I think you can do all this. Yeah, you should be able to do all this. And then we do the rest in the class.